Hey, good afternoon, everybody. Thanks for joining us today on our webinar, Dry Ice Blasting, The Secret to Food Safety. I'll be your host this afternoon. I'm Mike Henderson. Thanks for joining us. A little bit about me. There's a picture of me back in March of 1994, over 31 years ago. I spent 30 years on the road doing demonstrations, installations, consultations, and a great deal of them were in the food processing world. And hopefully, I can convey some of what I learned to you today. All right, let's get started. I'm broadcasting live from our global headquarters here in Loveland, Ohio. That's our plant right there. That's where we house all of our administration and we warehouse parts, and our world-class manufacturing facility where we machine and laser cut and press brake and weld and assemble our equipment. We also have bricks and mortar in Canada, Mexico, Belgium, Denmark, Germany, Poland, Spain, China, Japan, and Rancho Cucamonga, California, of all places. We are big in, well, we invented this thing back 40 years ago, and we still continue to take about 7.5% of what we earn and develop this technology and to make it better and more reliable and easier to use and give it more duty cycle. We also hold 250 worldwide patents. We are not the low-cost provider of this kind of equipment, but this is why. We build the greatest machine ever. And if you have one, you probably already know that. Okay, good. All right, let's talk about dry ice. What is dry ice? Dry ice is just made from CO2. The CO2 is out here in the air. It comes off of the ocean. It comes out of the volcano, comes out of our tailpipe. We all know that. All right. Dry ice is made from CO2. Dry ice is 109 below zero. We all know it's cold. Dry ice sublimates, which means it goes from a solid to a gas, not to be confused with evaporation, which is when it goes from a liquid to a vapor. When sublimation occurs, it leaves zero residue or water or secondary waste stream, and you'll hear me say that a lot. Dry ice is safe for hundreds of applications and really big in the food world, and I'm going to tell you why. Dry ice is made from recycled CO2, and here's how that works. Okay, so when you distill grain to make ethanol or alcohol or a spirit, okay, it's made in a big moonshine still, all right? And so you get a solid runoff of pure CO2. And there's also a movement now to capture the methane from farms, farm waste, animals, and composting. Put off methane, and so we capture that and through a carbon capture separate the CO2 from it. Okay, so then when you take the CO2 and pressurize it, it turns into liquid, so it turns into LCO2. And that way it can be stored and trucked and traveled to a site where they're going to make dry ice out of it. So here's how that looks. Okay, so here's a guy, he's making dry ice. He's received a silo of CO2 there, LCO2 rather, and it's piped over to the cold jet machine. Now, we do make the best cleaning machine in the world, but we also make the best dry ice production equipment, and that's what that is right there. Inside that box is a big hydraulic pump, and that powers a hydraulic ram and piston, and that is behind a stainless steel barrel and extrusion die. When we feed the LCO2 into that barrel, it experiences an atmospheric pressure change and flashes into a snow. So you get a snowstorm going in that barrel, and it fills up, and that activates the piston, and it shoves it through the extrusion die. We call it a spaghetti die because it looks like spaghetti when it comes out. And then when it falls into the storage container, it's brittle, so it breaks into more uniform 3mm blasting pellets. Okay, I'm going to read this because it's important. The California Air Resources Board is the toughest governing agency on the planet when it comes to greenhouse gases and related things. Okay, they state, and I quote, due to the fact that dry ice is recycled CO2, it will not contribute to your greenhouse gas score. In the calculation of carbon footprint, CO2 is counted for at the producer level. It is not counted a second time at the user level. So the ethanol plant or the farm pays for the carbon footprint. You need not worry about it. Oftentimes, when people start talking about dry ice cleaning, someone goes, "Oh my gosh, no, the carbon footprint." You don't have to worry about that. It's already taken care of. All right. Traditionally, and for years and years since the beginning of time, people are washing things with water, and water is often taken for granted, because it's coming out of the spigot. Everybody thinks it's free. It's really not. You pay for it twice. You pay for it when it comes in, and you pay for it when it goes down the drain. The water that comes in the plant, 40% of it is made for mixing ingredients and washing hands and flushing toilets and stuff like that. But 60% of it is used to clean stuff, and it all ends up down the drain. There are also a lot of safety concerns with the water. If the water is puddled up or improperly managed, or it's setting somewhere, it becomes a breeding ground for bacteria, which is what we don't want. Then the handling costs for water are very high, and that, especially if you've got food in it, suspended solid, can violate permits and environmental regulations. So now you're getting fines along with your water bill. Also, the other bad thing about water, if you're sitting around waiting for the water to dry to turn the machine on to make the cookies or whatever you're making today, that's downtime. Use dry ice, it's already dry. Dry ice is non-toxic and food safe. So here are various snippets from the USDA, FDA, and the EPA. When we put this together, we were chuckling that the FDA letter that we have there is time-stamped 1987. And so this is nothing new. We've been doing this for 40 years. But we believe that we've really scratched the surface on education. That's why we're doing this, because people are still using the water, and water's getting tough. Okay, here's how dry ice blasting works. There are three things that happen when you dry ice clean. All right. First, there's the kinetic energy, or the scrubbing action. All right. When that pellet comes out, it strikes the surface. There's some scrubbing. Now, it's not enough to abrade metals, and we're going to talk more about that in a minute. Okay. Secondly, there's a thermal shock. Okay. So the contaminant, or soils in your case, become cold faster than what they are stuck to. So they expand and release their bond. And then they fall onto the floor where you can sweep them up. They don't readhere, or you can catch it on a drop cloth or something. Then there is something called gas expansion. So we extruded that pellet at high pressure. That means there's energy in the pellet. So when we force its sublimation, it expands 800 times its size, which gives the soil a lifting effect. So if you've ever shoveled a driveway, once you get up underneath it, it kind of makes it easier to pop up. That's exactly what gas expansion is, okay? Then it all sublimates back to a gas. You never even see the pellet. A lot of people fear that the pellet is going to now bounce onto the operator or around the work area. That doesn't happen. All you see coming out of that nozzle is a vapor path, just like you see right there. Okay, so you have the scrubbing action, the thermal shock, the gas expansion, and then the sublimation. Easy, right? Okay. All right. When it comes, we have 100 applications in 52 industries. A good deal of it is the food business. And the type of soils things that we're talking about soils. All right. In our world, we have dry soils and wet soils, and it is just kind of understood that like cleans like. So with a dry soil, you would use a dry brush or a scraper or something of that nature. And of course, with wet contaminants or soils, you would use wet cleaning, waters, detergents, things like that. Now, the fact is, dry ice is not like anything. So it cleans everything. It's real good on dry stuff and it's real good on wet stuff. What kinds of surfaces? Well, the direct food contact surfaces. We're cleaning oven surfaces, and we're cleaning conveyor belts, and we're cleaning mixing equipment, and we're cleaning all kinds of stuff like that. Indirect food contacts, the guarding, the plexiglass, the stuff like that. And then there's non-food contact surfaces, so floors, walls, ceilings, forklifts, pallet jacks, the little stanchions that the mop will throw stuff onto, and they're just always dirty. Works great on those. Water, we're really reducing the water. Look how that is cleaning that stuff right off of there with any water. That's probably dough. Look at that tricky, intricate conveyor. It's pulling that dough right off, and so the operator's not working that hard. He's literally just holding that nozzle as it, and he moves it over as he cleans it. That's chocolate off the back of a pan. Chocolate responds very well to thermal shock. Look how clean that is. Okay, here's a flour and water. Flour and water makes glue, or paper mache. It's very hard to clean. Lots of water and chemical and detergent. This pops it right off. Detergent free. Now, so to get down in that tricky surface, that's probably baked on. You have to put some stuff down in there and then try to rinse it off because you can't get your fingers down there, or scrub brush. That guy's probably never had it that clean. That dry ice is cleaning that right up. Look at all that chocolate. Could you imagine if you had to hot wash or steam all that chocolate off, the giant chocolate river you'd have to clean up or put down the drain? When it pops off like that, it pops off as chocolate. You just sweep it up and you can put it in the farm waste, in the bakery feeds or whatever. Here, look how well it's cleaning that conveyor system. It gets all down in the nooks and crannies and hinges of that thing. Look at this guy cleaning the underside of that conveyor belt. That is the easiest job in the plant. Same here. Intricate surfaces, very delicate, cleaning it right up. Okay, enough about that. Okay, we clean things while they're hot. That's a peanut roaster right there. And this often immediately gets dismissed because, oh my gosh, that thing's 300 degrees. You're going to throw dry ice at it. It's going to cause it to crack. It does not. We are only changing the surface temperature by about 25 degrees. So you can clean things while they're hot. And that's what's great about this thing. You have to tear that whole thing apart and clean it and put it back together. Same thing with this. Could you imagine removing all those hearths and cleaning them and rinsing them and then putting them all back together? The cool down time, the startup problems. I'm going to talk more about that one in a little bit. Okay. We use the word dry ice blasting because we use this for all kinds of stuff, so we got to cover a lot of bases. But blasting by definition is the abrasion of metal. Okay. Back 100 years ago, there was a guy named Frederick Mohs, and he created what is called the Mohs hardness scale. And what he was trying to do is give a score to different materials or aggregates so people would know what to expect when they threw it at a substrate. Okay. So talc is scored as a number 1. Diamond is a 10. Dry ice is a 1.5. Shoot your fingernails only a 2.5. It's not even as hard as your fingernail. So, and the reason I'm telling you this is because oftentimes someone says, hey, why don't we look at dry ice blasting? Someone will go, oh no, blasting, that puts metal into the food. It does not. It's very gentle. We often joke that we can take the M off an M&M, okay? But it's true. Yeah, that's what I'm doing right here. I clean that M right off that M&M, and because it's chemical free, I'm eating it. And I just noticed that they put the M&M guy that looks just like me in there. Very funny, guys. Uh, all right, I'm gonna let you watch that again. See, look, I look just like that guy. That is hilarious. Good. Okay. All right. So, but we're cleaning all kinds of delicate stuff. Look how dirty that conveyor is, and just effortlessly, he is cleaning the grease, oil, and dirt out of all those moving parts. A lot of moving parts on that thing, and that plastic is rather delicate. And we're able to clean it while it's online. Non-corrosive. Well, you're using detergents and corrosives. Yeah, you got a lot of stainless steel, but there's a lot of metal parts. Those that washers and bolts and things are going to corrode. Just like here, watch this chain here. Isn't that beautiful? Look at that. um, that's because he put a corrosive on it, and now he's got a problem with that chain. And when it's corroded like that, it doesn't move as well. You can cold jet that thing with no effort, and you don't have to relubricate the chain or anything like that. I think that's great. Electronics. This is non-conductive. You can go right. You can shoot this thing right in the to electrical outlet, but it's great when you have these control panels and stuff, because they get guys are touching them all day, and they get gooey and hard to unpleasant and sticky. Also, these the data panels and control panels. That guy, I remember doing that. That guy was scared to death to let me do it, but really, we do. We're a machine shop here. We clean our own stuff like that. But when the machine is clean and the operator, the morale goes up and attendance gets better and stuff like that. But nobody likes to work on a dirty machine. Okay, this is what we're really talking about, and this is what nobody. We don't want to get on the news with a recall. Okay, that is horribly um, damaging to your reputation and so forth. Um, I looked it up. In 2024, there were some 1,900 recalls in the United States, costing food processors about $2 billion. All right, it's a big deal. We got a call here from a lettuce manufacturer, a producer that was bagging lettuce, and we went out and saw them, and sure enough, it was puddled water that they didn't see that was the problem, and we showed them how to dry ice it, and no more problem. We had the same problem with a pet food plant. That pet food plant now owns probably 50 cold jets around the planet. Okay, productivity improvement. This is a great one. I actually was pulling the trigger on that right there, and that was a long time ago. But this is an ice cream cone plant out. I believe this was out in Omaha. It's the biggest ice cream cone plant in the world. So this is a book oven. A book oven is, it opens up, you pour the batter in, it closes, it goes through the oven, okay, and then out comes the ice cream cone, and then they curl it into a cone. All right. So once the thing gets dirty enough, the sugar, see that one? See right there? That sugar carbon builds up. It doesn't make very good ice cream cones. So they have to shut this thing off. They wait for it to cool down, 380 degrees. All right. Then they disassemble. They take all the books out, and then they take terry towels and soak them in caustic soda, and they put it in the book, and they shut it up, and they let it set. Then they come back and wire wheel it because it's a knurled surface. You got to get down in those grooves. All right. Then they take a water cannon and rinse it all off, and then they put it all back on the oven, and then heat it back up. Okay. Here's what happens. A, you're waiting for the oven to cool down time. Okay. B, the caustic soda deseasons the iron. So now you've got to throw away thousands of ice cream cones because they taste like Easy Off. They're just a huge open top dumpster out back full of ice cream cones. Then the wire wheel loses the bristles. So now they have metal detection in the packaging area looking for these bristles, and they lose them. Then when you rinse the caustic off the iron, it washes the high temperature lubricant out of the hinge, and it's very expensive to re-lubricate that oven. Then reassemble and heat back up. And the guy told me, and this was 20 years ago, it costs a few $1,000s in natural gas to heat that oven up. I can't imagine what it is now. But I clean that oven in less than 2 hours without any shutdown, without any soda, without any wire wheels, without any relubrication, and without any heat up. Can you imagine the throughput that they gained and the cost savings and the well, they were thrilled. They bought plenty of our equipment, and it's become a standard for this kind of an oven. But it's the same thing with band ovens or hearth ovens or any kind of ovens. You can clean them hot and without any caustic soda and mechanical use. In the beverage business, Ben, from the plant where they make the can or the bottle, it all begins there. The molds get cleaned, the stamping gear that stamps the can out gets cleaned, the decorating, the ink, the varnishing all gets cleaned. And then once they produce the can, they all ride around the plant on this thing. It's called Airvare, all right? And it's basically an air hockey table. Jets of air are the can's right on a bed of air, and they're going by at 100 miles an hour. Well, if that thing gets dirty and a can trips, it causes a domino effect, and it goes all through the plant, and it happens in a second. And I'll never forget the first time I went to one. They were having a big day because the day before they only lost 250,000 cans that day, and it was a banner day. Because this thing is hard to clean, and so they just don't clean it until they have a problem. And what they have to do is they take a brush and they go down each and every single one of those holes. Can you imagine? I can clean that Airvare 10 linear feet a minute. Okay, and that's amazing to them. But then the cans go to the filling plant, where, they're filling it with pop or beer or whatever. It's all sticky stuff, and the conveyors and the motors and everything get dirty. And then it goes to the packaging area. Well, if you've ever seen a packer, this thing opens up a 12-pack, glues one end, throws in 12 cans, glues another, sends it through. Well, this thing gets overwhelmed with the carton dust, and it gets in all the moving parts, and now it's starting to malfunction. And then the lithography, they call it, but it's the not quite dry ink from the carton causes the grippers to become slippery. Now that doesn't pull through. Then the glue gets spattered all over everything. And if you ever seen one of those glue nozzles and they get clogged up, now a guy goes out there with a torch and tries to torch it all off, which is very unpleasant, or they just replace it. And those nozzles are thousands of dollars. Okay, this guy told me it takes 5 guys, 3 shifts to clean one. I cleaned one by myself, front to back, in 20 minutes. All right, it's really fast and really thorough. Then when it leaves the packer, it's got to go up a roller. This is getting coated in glue and lithography. Then the boxes get oriented so they palletize well. Sometimes the boxes break open and pop gets spilled all over the palletizer. All can be cleaned with cold jet. So from the beginning to the end, we're cleaning the packaging and beverage lines. Okay, so this says labor costs for cleaning staff typically range 40 to 60%. Well, okay, the numbers are the numbers, but that's great. But look how this is not easy work for this guy. Look at the rain gear and all the PPE he's got to wear. My guy on the right here is cleaning that dough off, and it's nice and cool, and it's very satisfying, and it's not killing the guy. Look at this guy. He's just wearing safety glasses and earplugs. He's cleaning that horizontal mixer. Look how beautiful that is. So anyway, the guy that gets to run this thing is the happiest guy. Look at this. There's one of those Procter and Schwartz dryer ovens with that's granola, and it's cake dipped with syrup and fruit juice and stuff, and they're hard to clean. Can you imagine all that water and granola on the floor? Look, he's cleaning that grease off that and exposing the factory paint. Again, here's the guy underneath the conveyor. That's really difficult to clean. Look at the guy on the left. What would you rather do, the guy on the left or the guy on the right? I take the guy on the right. Water. Again, 60% of the water goes to cleaning. Look at this river running through the plant with all the food in it. This is a reality, okay? On the right, no water. We're cleaning those rollers. Look how nicely that fitting is being cleaned. And the reason it doesn't get cleaned because there's no time to clean it. If you make extra time, that stuff gets cleaned. So it's the important stuff that gets cleaned, and then the ancillary, unsightly stuff just goes unnoticed. Look how well that's working on the right, and that's just can go to the farm. We can also angle it up. That's a cheese melter in a pizza plant. It kind of half melts the cheese, but they get greasy. Here's something that's got electronics in it. He's cleaning it right up. How else would you clean that? You cannot possibly clean that with water. Okay, energy savings. Okay, that is a motor. You'd think that motor was in an oil refinery. It's not. That isn't a, I'm not going to say who it is, but that's a dry ingredient company. And when the motors get hot, like dirty like that, they don't cool properly. And its design point is it needs to cool, because if it's running hot like that, it draws more energy. So that thing's running about 5 amp higher than it needs to. Now, if you're a regular size plant, and if you go around and start counting the motors, you'd probably have 1,000 motors. If they're all dirty like that, they're all running 5 amp higher than they're supposed to, that could be $30,000 to $50,000 a month in unnecessary electric bill. So, most people buy a little too much dry ice because it's better to have more than not enough. But if you simply go around and clean your motors and control panels and moving parts and stuff like that, your energy bills come way down. Okay? All right. So, here's a to-do list. We're going to get ready to clean something, right? All right. So, there's all the pre-cleaning checklist. You got to remove all the bulk food, cool things down, take things apart, wrap all the electronics, right? Because you won't get them wet. Then there's pre-treating. You got to set up containment because you don't want everything to end up over there, right? And then you start cleaning, scrubbing, scraping, detailing, picking, vacuuming, pressure washing, okay? And then there's post-cleaning. Well, you've got to pick up, collect all that water or get it into the drain, reassemble everything, re-lubricate, make sure the electronics are right. Okay, that's a lot of stuff. When you dry ice it, we're talking about this. All of that goes away. We're just cleaning. All right? And now, you still got to sanitize. And let's talk about that real quick. So, this gal's swabbing this surface. Now, if I dry ice that surface where she is, she's going to get a 0, all right? But we're not exactly sure, nor can anybody attest that because we're using compressed air, we're not sending it over here, okay? So you still need chlorine or alcohol or however you like to sanitize. But when you're dry icing, you're cleaning everything in less time, giving you more time to do a more thorough sanitization process and better testing. It's easier on the operator, and you get a deeper, more thorough clean, resulting in improved log readings. You have less downtime, less scrap, less risk, which is the real expensive one, and you can make more product. You get more throughput. Okay, who's using this? Everybody. Pet food people all over this thing. The dairies, frozen food facilities. If you want to go and clean a cold storage, you got to warm it up before you can clean, because you can't take water and hot soapy stuff in there, but you can take dry ice in there and clean. Snack foods, my God, if you're making any kind of cookies, crackers, ho-hos, king dongs, whatever, a lot of these guys, Little Debbie's, all these guys are using dry ice. Chocolate responds well to thermal shock. Those chocolate enrobers and conveyors works very well. That plant up there in Pennsylvania has about 35 of these things. Ingredient spice blenders, dry mix blenders, nuts and peanut butter all have these things. We are effective from the beginning to the end. So people are cleaning silos, with, the silo from the outside air cools and heats and the inside walls get goofy. Those are easy. We can clean. You can cold jet those. But the conveyor systems and radial feeders all can be cleaned. All these rollers get cleaned. They're hard to clean. Then all the mixing agreement. That's cheese right there, okay? If you get that cheese all wet trying to wash it down, it ends up in the drain. If you do it this way, you can scoop it up and put it in the dumpster or send it to the farm. Okay. But mixer vats, extruders, dough dividers, batter hitters, there's a ribbon mixer. Look how well it's cleaning. Yeah, this again, back with the McGriddle, they almost, after spending millions of dollars, canceled that whole program because they couldn't keep the oven from catching on fire. And if you look on the side there where that the conveyor is, there's a fire going on. And they have guys running up and down the side of the oven, squirting the fire out. Now, we saved that program because they put the syrup in the batter, and the batter fouls the hearth, and it causes problems. But they down there where they make those things, they have a lot of cold jets, and they're cleaning them. Also, this dryer bed, back to the granola, it's very difficult to get that thing clean because what happens is the holes get clogged with juice and stuff, and it doesn't breathe properly, which causes the energy bill to go up. Okay, here's that thing's a pie pan for a pizza pie. Again, lots and lots of applications. The packaging and labeling. Well, I talked about the packer, but here this guy's cleaning the rollers that take the packaging up to the palletizer. They get covered in ink and glue and carton dust. Also, all these chains and these conveyor mechanisms, they're hard to clean because how are you going to clean them? You can't get all that stuff wet. This is completely dry. Look at that chain. That is great. And you don't have to relubricate it. And that thing's never been that clean. And then you have ancillary applications. Now look at this forklift at a dairy. This thing is just covered in spoiled milk. All right. And what's going on here is, a guy is going to drive this thing all over the plant, and it's contaminated with spoiled milk. And secondly, a guy has to sit in this thing and drive it all day. Next, these things require a lot of PM. How are you going to PM this thing with rotten milk all over it? So the PMs don't get done properly. When it's clean, it gets done. But so there's all kinds of, just general maintenance, motors, control panels, fans. You don't clean man fans, they get off kilter. And then you got to replace them. You can clean them while they're online. These misstuck labels. I know one company has 42 cold jets cleaning these misstuck labels off of everything. That one right there, I think, is on a beer keg. But it goes on and on. There's big evaporators that go on the wall. The fins get clogged and it causes the electric bill to come up. You can clean these. That's milk in a cold storage. Okay. How else are you going to do it? You clean that with water. You got a lot of water and milk in the drain. Okay, what do you need to set this up? Okay, this thing runs on compressed air. A little bit of electricity. You just plug it into the wall. You need a dry ice source, which we're going to talk about in a second. And, of course, you need a cold jet. If, for some reason, you are going to do your cleaning while the plant is down, you may have your compressor down too. You just need to call the tool rental and have an air compressor delivered. Now, the portable air that you rent is probably not nice, clean air. It's probably dirty, wet air. Dry ice doesn't like wet or dirty or hot. So we would have to put a mechanism in the middle of that to clean up the air. And we can show you how to do that. It's not a big deal. I get this a lot. How do I know what machine to buy? Well, we have entry-level models. All the way on the left there, that's an entry-level model. For the occasional user, spot cleaner, or something like that. And then to the right of it is a more robust version of that. Okay, so now this thing, you can see the wheels are big, nice wheels for bumping over difficult terrain. Foam-filled pneumatic tires, welded steel, 18-gauge stainless. It has multiple agitation. It has a great big electric motor in it, giving you a lot longer duty cycle. And then to the right, we have our smart equipment, okay? By smart, I mean this. There are four things that can affect the outcome, okay? That is air pressure, feed rate, or pounds per minute, and then particle size, okay? So if you're trying to do some hardcore fast cleaning, of course you're going to throw the 3 millimeter pellet at it. But if you want to take the M off the M&M, or if you want to get real gentle like on those plastic conveyors and stuff, you need to dial that down, and this thing custom cuts the pellet down to 0.3 millimeters, all right? Now, you can then set that up as a recipe, all right? So the operator knows when we clean that over there, we use recipe number 2, because we don't want them to underdo it, but we don't want them to overdo it either, because now you're just burning up your ice. Then it sends a report to the supervisor stating, hey, Joe is cleaning today. He used this much ice and this much, ran this much trigger time. Because if you cleaned it with 40 pounds one week and 400 pounds the next week, we've got to understand that better. But also that report can be then go into a file. So if you have an incident or a recall down the road, heaven forbid, you can then reach in your file and go, no, we cleaned it. It was cleaned, and here's the report. It also, it has IoT in it. So if it starts to feel funny, meaning if one of the motors is pulling a funny amperage or a circuit board is sparking funny, it will send an alert to the supervisor. And then we can go, it has a health screen. We can get on there and look at it with you and determine what we need to do. If we need to dispatch a service tech or send a part out before it becomes catastrophic, because the last thing you want is this thing to be idle while your ice is sublimating and your guys are standing around and you've already shut the plant down, right? So, and we'll talk more about that in a second. Okay. Where do you get the dry ice? Well, wherever you buy your industrial gases. So Airgas, Praxair, Linde rather. You can also get it from a number of independent welding supplies. Sutton Garden, Emery, Holston Gases all sell dry ice, as do a number of others. There are also a lot of independent dry ice manufacturers. And our field guys, the sales manager and the technician, all know these guys very well. So we will help you find the right supplier and help you negotiate the right price for your needs. There are various sizes of ice. So the guy with a handful on the left, those are 3 millimeter blasting pellets. That's what's used for cleaning. On the right, that's a 16 millimeter nugget, they call it, which is used for shipping and processing and stuff like that. Down below, you see dry ice on a national level is 30 to 80 cents a pound, depending on how far away you are from the source. So it's the transportation cost that causes it to vary. Going forward, I'm going to use 50 cents a pound for math, and you'll see why in a second. Okay. Often asked, should I make my own dry ice? Maybe. We sell these pelletizers. We'd love for you to buy one. But it's expensive. I'm not going to lie to you. First of all, you have to install a 40-ton LCO2 vessel so that you can receive the LCO2. Now, if you're a food plant, you may already have this on site. If you have one, you're halfway there. All right. But that's not it. The thing is that the Airgas and those guys probably can make it cheaper than you because they probably have better buying power on the liquid. And although we'd love you'd buy one, unless you're making 4,000 or buying 4,000 pounds a week, you probably don't have a case to buy it. But if you are, then call us because we're going to send a guy out to help you work through the math of it all. The next question I get a lot is, how do I know how to budget how much ice to buy? Okay, well, an average operator is going to use about 100 pounds an hour, okay? At 50 cents a pound, that's about $50 an hour. Of course, if it's 30 cents a pound, that's $30 an hour, right? Now, the guy also has set up, shut down, breaks, lunch. He's going to move it from here to there, So an average operator will use one of those blue totes, that's a 500-pound tote, per 8 hours of scheduled cleaning. All right, so for instance, if you're going to clean on Tuesday night, Thursday night, and Saturday morning, you would receive 3 boxes on Monday. It keeps for a week. Now you lose a little bit every day, but it's not enough that you would notice or would affect your cleaning. All right. And then you break them open as you need them. And then next Monday, the supplier will bring you 3 new boxes and pick up the empties. It all runs very smoothly. It's just a whole milk run. How am I going to learn to use this thing? Well, we're going to train you. So when we deliver the machine, we'll set it up and train everybody. We have 24 hours tech support. We have parts right here in the plant. We can ship you overnight. Then we do something that nobody in the planet does, okay? Once a year, our field tech will call you and schedule a visit where he's going to perform a free preventative maintenance inspection. He'll put a safety sticker on the machine. He'll retrain new personnel. If it happens to need something, he's got it on the truck, okay? But if you get a brand new guy and you want to train him quick, there's a QR code on the machine. He can take a picture of that and download the entire manual and watch an entire training video right on his phone, okay? What have we learned today? Well, we've learned that dry ice is non-toxic and food safe. We dramatically reduce or hopefully eliminate all your water and chemical usage. We can clean things while they're hot and online. We've learned that dry ice is not abrasive, non-corrosive, non-conductive. We learned that we not only reduce the labor that is done is far more pleasant than the current way you're doing it. We reduce all your cleaning and sanitation time, giving you more time to do other stuff. We've learned that dry ice is easy to get and affordable. And we've learned that setup is easy and you can learn to use this thing in about 10 minutes. That is the end of my webinar. I want to take some questions. I got to go over here and do this. Okay, question number 1. Is it intrinsically safe? So this person wants to know if we can run it in a class 1, div 1 explosion area, so like in a flour or sugar plant. Well, there is a motor in the machine, so we have a spark, okay? Now, you could park it outside, and we do have a pneumatically driven motor, okay? But still, there is static in the line. So when you send pellets through a polyfoam, a hose, you're stripping electrons, so you're making static. So you have to know a lot about grounding and stuff. But we do have people that do it. They simply clean the plant to a point where there's not a lot of dust in there, and they can issue a hot work permit. So that's a kind of a plant policy thing. Can it be done? Sure. Is this intrinsically safe? No. What about PPE? Well, again, that's an in-house policy thing. Our manual says wear everything known to man because we have to cover our tushes, but really, a pair of cotton gloves, safety glasses, and earplugs are all you need, and you're probably using those already. Is the dry ice food grade? Yes. You'll find that almost all the dry ice suppliers are supplying this to the food plants for their shipping, so they're already used to your needs for it being food grade. So they wash the boxes and then they put a food grade liner in the box. So yeah, all your dry ice is food grade. Question. Is there any study validation on this killing pathogens and removing biofilms? Do you need to still use a sanitizer after cleaning with dry ice? Also, is it good to use on Teflon parts? And then how much does it cost? Okay. So no, there is no study on the validation of cleaning, killing pathogens. Well, and we never claim that we do that. That's why you still need to sanitize. And you might have typed your question before, but you still need to sanitize because it's invisible. We don't know. Is it good on Teflon parts? Sure. You just got to turn it down. I can take the M off an M&M. Okay. All right. Do we have applications in pet food? Yes, it goes on and on. I have been to many a food plant, starting with the mixing of the stock to the extruder to the drying bed to the oven, the conveyor, the buckets all the way up top. So because it comes down through the sheeter wares and the bagging, yeah. Most pet food plants I know have 2 or 3 or more cold jets. Um, we got to protect Fido, right? Does it work well in beverage facilities? Yeah. All these Coke, Pepsi, RC Cola, beverages, I'm sorry, breweries love this thing for the conveyors and the fillers and the, packaging equipment and all that. Paint removal. We have never sold this as a paint removal method. Okay. Now, we can clean failing paint. All right. So poorly adhered, flaky paint, sure. But well adhered powder coats and 2-part epoxy, absolutely not. That's not our game. You mentioned that your machines are IoT capable. Does that mean that ColdJet can essentially remotely diagnose any issue I am having to give support to? Any issue, probably. Every single. I mean, I don't want to say everything, but mostly just through conversation we can do it. But with the IoT on the smart machines, yeah, we can get a look at motor number 3 and see what it's doing. How high can I go up? Okay, hold on. I'm going too fast for me. Here we go. Okay. There are lots of applications in rendering. Rendering is dirty. And if you've ever been to a rendering plant, earplugs and nose plugs, of course. But there's a lot of grease and fats and things that remove well with dry ice. And it goes right to the motors. The motors are always dirty and they're clogged up, and fans that get dirty and stuff like that. How high can I go up with the hose? You can go 100 feet straight up. And this is big in dog food or pet food because, they after they cook it, they bucket it way up high. So because they let the gravity get down to the weighing system to the baggers. So it's very important to be able to get up high. But yeah, you go 100 feet straight up if you have the right air. The next question is risk of suffocation. Well, yes. Okay, the way dry ice works and CO2 works, when you force the sublimation of that pellet, the CO2 goes down to the floor, out to the wall, and up to your nose. All right? If you're in a confined space, yes, you have to make up that air. You have to exhaust it and make it up. All right? Now, if you're out in a 50,000 square foot plant, it's just going to find its way out a dock door. So, yeah, you have to lock out a pit if you have a pit. So, yeah, you have to understand CO2, and we can train you on all of that. Where should the air compressor be installed to reach many areas? Well, if you are a food processing plant, you probably have compressed air piped all over the place. We just have to find the right size airline. This to do the big jobs, not micro jobs, but big jobs, you need 130 CFM of air. So you're going to want to get on a 3/4 or 1-inch airline. So you don't need to move the compressor. You simply just latch on to the already piped in air. And our field people can help you with that. How does it work for facilities with allergens and cross-contamination with material being sprayed around? Well, you would do it the same way you would do it with water. If you're making a peanut product over here and you don't want it to get over here, you've got to set up containment. The same way you would if you use water. None of that changes. We can't see where the allergens are going in because we're using compressed air. Okay. Can we use the Aero 40 or the Aero 80 for delicate parts, electronic, and which nozzles variable fragmenting would be to reduce particles less than 3 minutes? Well, there's a number of fragmenting nozzles. Yes, when you use an Aero 40 or Aero 80 product, the fragmentation is done at the nozzle. And Frankly, I like that because the operator can do it on the fly. But any one of these we have a whole line of them. Nozzles you can fragment with, and it works. It works great. Yeah. What's the difference between dry ice and steam cleaning? Well, steam's water. Water. You got the same kinds of problems. Now there is dry steam out there, which a lot of people use. It's a big expensive thing, but the problem with dry steam is that you have to have 220 electricity to hook it up to. There's a huge energy draw. Secondly, if heaven forbid someone were to shoot you with the dry ice, he's going to say ouch. You get hit with that dry steam, you're going to the hospital, and that's a fact. Does it work well for the baking dry ingredients? I guess what you're asking me is, in a bakery, can you clean the ribbon mixers and stuff? Yes, you can. Now, you have to set up containment because the compressor is going to cause it to come out of the mixer. But you do a lot of vacuuming and stuff. Yeah, but it works real well. Does dry ice can be stored 5 to 6 days? Does it affect the quality of cleaning those last days? 5, 6 days? No. 7, 8 days? Maybe. It's not that it affects the cleaning. It doesn't feed through the machine very well. Because dry ice is a desiccant. All right, so it draws in moisture and then they stick together. So it has a hard time feeding through the machine. You'll have a hard time shoveling it out of the box. But if you keep it dry and keep the lid on it and stuff like that, there's no problem. You should have no problem. You shouldn't see no great difference in cleaning. You're using compressed air to remove debris. How far does the debris travel from the machinery, and how fine are the particles? How much cleanup is required after the blasting? Okay. Well, it varies from soil to soil. All right. But as a general rule of thumb, the debris is going to fall in somewhere 5 to 6 foot range, fall out. And you just sweep it up. It doesn't re-adhere, or you can catch it on something. I think that answers the question. How effective is the cold jet on meat and equipment? Well, what we're talking about, animal fat, you can clean all kinds of hangers and stuff like that, but you can clean stainless steel conveyors and things like that, but you develop a technique called squeegeing, where you get it all moving in one direction. But the big thing in the meat processing is people are taking the pellets and mixing it into the grinding and processing equipment because, there's friction down there and it causes the meat to cook a little bit or bring the temperature up. When you put the dry ice pellets in with the meat, it keeps it cool. Would this compromise galvanized or other coated steel surfaces? I've never heard of it compromising a galvanized or coated steel. No. I suppose you'd have to ask what is the coating. But no, I don't think so. Can you clean the inside of electrical panels? You sure can. Now, you don't want to go poking around in there with aluminum nozzle. You should shut it off. But yeah, you can clean a control panel right now and fast. Is this webinar recorded? If yes, would you be able to send the link? Yes, you will get, am I wrong? They will get a link? Yeah. Yeah, you're going to get a link to the webinar, and you feel free to share it around. How well does it work to clean buildup of fat like fryers, grills, commercial equipment, and restaurant level? I have, in the 31 years I've been here, I've never seen anybody make any money cleaning fryer hoods and fryers. Animal fat does not respond well to cold thermal shock. It responds well to heat and steam and stuff like that. Plus, the current chemicals and the way they do it now is so inexpensive that you couldn't compete with it even if it did work. I would stay away from restaurants. Can it be used on kitchen cabinets? It depends on what's on it. If you're trying to get the paint off or the stain off of it so you can restain them. Maybe, but it's a very expensive way to do that kind of a thing. I mean, you can buy a lot of sandpaper for what it would cost to do this. I would have to understand what you're trying to do better. Does a remarkable job on ink. Matter of fact, one of our target markets is printing presses. But if you're talking about in the food plant, yeah, the decorating cans and printing labels and video jet ink, sure, all day long. Inks, glues, things like that respond well to thermal shock and dry ice. I might have missed this part. How much does it reduce the time cleaning with dry ice than by hand? Well, you know, the example I have, you know, that book oven that they cleaned, it takes 3 days to clean that thing. By the time you shut it down, wire wheel it, caustic soda, soak it, put it back together, heat it back up, days. I cleaned that thing in 2 hours. All right. Every single thing, man, it's hard to give an example. If you got something for us to look at, call us. We'll come out and take a look at it. Can you use this for cleaning ceiling deck? If you're talking about a deck and grid ceiling, absolutely. A lot of bakeries, you know, they'll get a hot spot over the oven. Yeah, it does well on that. Well done presentation is very clear and informative. Thank you very much. Is it possible to schedule a tech to come out and demo a unit? Absolutely. One of my other jobs here when I'm not doing webinars is I answer the phone. So yeah, call in here. You'll probably get me. I'll put you in touch with the local technician or regional sales manager, and we will come out and see what you got. That's all the questions I have here. Thank you for joining me today. This was a thrill for me, and we hope you'll join us on our next one. Thanks a lot, everybody.